This class, I will be talking about chapter number 10, and in chapter number 10, we will be talking about the hypothesis testing. So let's start with the definition of hypothesis test. Hypothesis means claim about the population. Now, to make a claim about the population, first thing we need to do is to collect some sort of a sample and then apply some sort of statistical tool on that. And by applying the statistical tools, we will then try and make a claim about the population, that whether that claim is right or wrong. And same as what we did in chapter number 9, there will be a confidence interval around it. So a confidence interval of 95%, 99%, or maybe 80%, depending upon what the question is saying. Now let's try and understand what hypothesis means with the help of an example. Now I'm going to take an example here. Let's say in year 2000, there was a study conducted by Stat Canada where they found out the average age for a Canadian man when he first time gets married is 30 years. Average age is. Now in 2025, a researcher comes along and he says that, look, this is 2025 and this average age has changed now. So he can challenge this research work from year 2000 by three different ways. He can say that the average age is not equal to 30 years, and he can also say that average age has increased more than 30 years, or he can say the average age is less than 30 years. So these are the three different ways he can challenge it. Okay, now hopefully you were able to understand what we are about to do in this. And then he collects his data and then applies some sort of a statistical tool to figure out whether whatever he's claiming is right or wrong. And again, he does it based on these confidence interval on a 95-99% confidence interval. So that's what we do in the hypothesis test. Now, let's talk about some of the terminologies in hypothesis test. In hypothesis test, there are two things. One is null hypothesis, which is represented by HO, and this is called null hypothesis. Null hypothesis is always represented with equal to sign. So going back to the previous example where I said the average age of a Canadian man, according to Stat Canada, was 30 years. So I'm going to write mean value is equal to 30 years. Again, one more time, I'm repeating. So whenever you are representing the null hypothesis or writing the null hypothesis, it should always be with the equal to sign. Now, alternate hypothesis can vary depending upon what the claimant is saying. So alternate hypothesis is represented by, first of all, H1. And this can be average age is not equal to 30 years. It can be average age is greater than 30 years, average age is less than 30 years. So that's how we represent the hypothesis testing. All right, now let's try and understand this with the help of some more examples. So I'm gonna show you a couple of examples here. Now here we are given, according to the Stat Canada, the average age of a woman when they gave the birth to their first child was 28.5 years in 2011. A researcher believes that this number has increased since then. A large random sample of the first time mother is selected to test the researcher's claim. Now, what I wanted to do is that we wanted to state the null and alternate hypothesis and determine if it is a left tail, right tail, or a two tail. Okay. Now, another thing we wanted to do is determine the population parameter which is being used. So in this question, if I look at it carefully, the population parameter which is being used is the age, the mean average age. So if I write the null hypothesis, so null hypothesis will be mean, which is the population parameter, is equal to 28.5 years. And alternate hypothesis will become mean is not equal, whether it's a not equal to or greater than we will figure out by this line. A researcher believes that this number has increased since then. So mean is greater than 28.5 years. That's how we're gonna write it. Now, This is writing the null hypothesis and alternate hypothesis. The second thing the question is asking us also to find out whether it's a left tail, right tail, or two tail. That's what we will try and understand. What is the meaning of left tail, right tail, and the two tail method is. So if I go back to the hypothesis test down here, in this one, we wrote down the alternate hypothesis in three different ways. So whenever it is not equal to, on on a normal distribution graph, not equal to is represented with the help of two tails. Two tails. So one on the right side, one on the left hand side. And whenever it is greater than, it will be represented by the right tail. So something like this. That's how we will represent it, with the help of a right tail. Okay, now the third thing, uh, it is less than 30 years, so this will be represented with the help of a left tail. Left tail. All right, it will be like this. Now you may ask the question, what are these tails about? So tails are basically the confidence interval and the critical value. So if you can recall chapter number 9, where we talked about the critical values and the confidence interval. So confidence interval was, let's say, 95%. If the confidence interval is 95%, alpha value, which is level of significance, that becomes 5%, or we can write it as 0.05. Now, if it is a two tail, we can divide this alpha value over these two sections. So 2.5% on this side and 2.5% on this side. If it is only a right tail, then whole of the alpha value will be on the right side. So this section, oops, I don't know why my pen stopped working for a second. So this section will be 5% of the section. And again, if it is a left tail, in that scenario, this section will be 5% of the section. Again, same thing, if it is a confidence interval of 90%, then alpha value in that scenario will be 10%. And then if it is divided over the two regions, then I will write it as 5% on the right side, 5% on the left hand side. So this section is 5%, this other section is 5%. And if it is only right tail, so whole of the 10% is on the right hand side. If it is a left tail, then whole of the 10% is on the left hand side. So this section is 10%. So make sure you understand how to calculate the probabilities around it also, because that's also really important. So if I were to ask you to find the probability here, the probability value is 0.1 here. Okay, if I were to find out the probability at this point, the probability value will be 0.9 when it is a right tail. For same alpha, alpha here is 10%, but because this being the right tail, so this is the 10% of the right hand side of the section. So it means starting from the zero, probability always starts from the zero, moves in this direction. This is where the 90% of the probability value will be. And if I were to divide the alpha value over the two section, then the probability value here is 0.05, and here it will be 0.95, because 5%, this section is 90%, 90%, and this will be 5%, so total 100%. All right, so hopefully you were able to understand this part. So going back to the question, and if I were to draw the normal distribution graph for this question, how I'm going to draw it. So again, this is the normal distribution graph, and in this one, this is a right tail, so alpha value will be beyond this point. So this is the level of significance, or this region is also called critical region. Critical region. Critical region. And this value, whatever value you're going to get correspond to this z value, that will be critical value. Critical value. Critical value. All right. Now let's look into another question. Question number 2 on this one. Okay, according to the Stat Canada, the average weight of a baby born in Canada in 2013 was 3.35 kg. A researcher believes that this number has changed since then. A large random sample of newborn babies is selected to test the researcher's claim. Okay, so now the researcher's claim is that the number has changed since then. He's not saying whether it has increased or decreased. So let's see how we're going to write the hypothesis test. So null hypothesis is, again, we are using the mean. Mean is equal to 3.35 kgs. And alternate hypothesis H1, alternate hypothesis will be equal to, uh, that is not equal to, shall I say, not equal to 3.35 kg. And if I were to draw the diagram for this one, it will be a two-tail. Okay, now let's look into the third one. According to the 2006 census, approximately 68.4% of the Canadians own their home. A researcher believes that this number has decreased since then. A large random sample of Canadian households is selected to test this claim. Now, what is the parameter which is being used when you are given the percentage? It will be proportion. So I'll do it on this side. So null hypothesis will be proportion is equal to 68.4%. Okay, so 68.4% own their house. And alternate hypothesis in that scenario, P is less than 68.4%. And then if I were to draw it on the normal distribution graph, it will be a left tail. So hopefully you were able to understand some basics about the normal distribution graph and its hypothesis testing. In the next video, I will talk about I'll try to solve some problems on the hypothesis test. Till then, goodbye.